When we graph things or functions, we are accustomed to using a rectangular coordinate system where any point that we represent using the two coordinates, the horizontal direction and the vertical direction. So point is x, y. And these it creates a rectangle, if we think about this, with the origin at one corner and this point x, y at the other corner. So we have this, it's a rectangular, it's called a rectangular coordinate system because of this rectangle. Every point is represented as the horizontal length of the rectangle, and the vertical second coordinate is the vertical length. Well, this is a rectangular coordinate system, but sometimes measuring in that way is kind of restrictive. And so we'd actually like to have a different way of measuring, and this is going to be the polar coordinate system. So the polar coordinate system, we're still going to measure things in two ways, but we need kind of a framework. Just like here we have our x and y axes, we are going to have what's called the pole, and we're going to have then an axis. This is called the polar axis. And you'll notice that the polar axis, it is a ray coming from the pole, with the pole at the initial point of the ray, and then moving in to the right, corresponding to the positive x-axis. So you can kind of see that there's some similarities here. First of all, the origin of the rectangular coordinate system is just like the pole of the polar system. And then we have an axis in the polar system. We've got two axes in the rectangular system. Now, when we have a point in the polar system, we're not going to create a rectangle out of it. We're going to just connect directly from the pole to that point. And that distance we're going to call r. And the point creates an angle with the polar axis. That angle we're going to call theta. And then this point we denote by the coordinates r, theta. So the first coordinate represents the distance from the pole. The second coordinate represents the angle between the polar axis and the side connecting the pole to the point. That's how we represent points in the polar system. Now, you'll notice there's actually multiple ways to represent a point in the polar system, because this angle there is just one of many. We could have gone in an opposite direction. We could have gone from here and then gone all the way around like that. And that would have been a different angle with the same terminal side. So coterminal angles can be used for this spot here. Also, and I should mention, of course, that the angles are measured in the standard way, where counterclockwise is a positive angle and clockwise is a negative angle. Another way that we can adjust how we represent this point is if r is a negative number, it actually moves in the opposite direction from the pole. Okay, so for example, I'll have a very, very simple example here. Here's my polar axis and my pole. Okay, if I were to say, look at a point that's out here, okay, in a distance of 3 from the pole, this point I can represent as a distance of 3 at an angle of 0. However, I can also think of it as on the opposite side of over here. If I were to think about this over here, okay, then a distance of 1, 2, 3 out here, that distance of 3 is at an angle of pi. But if I then go in the opposite direction, that's a negative 3, okay, r being a negative number goes in the opposite direction from the pole, and that was at an angle of pi. So this point, right, can be represented as 3, 0 or negative 3 pi. It could also be represented as 3, 2 pi. Okay, so you can see there are an infinite number of ways to represent a point in the polar plane. This is something that is special to the polar system that we do not have in the rectangular coordinate system, right? In the rectangular coordinate system, any point can only be represented in one way. So these now we have this new system, okay? Our old system was the rectangular system. It's also actually called the Cartesian plane or Cartesian system, named after René Descartes. So this is the rectangular system, and this here is the polar system. Okay, created, of course, from the pole. That's why it's called polar. And there are many different graphs, behaviors that are really easy to represent in a polar form that are not very fun, pretty complicated in the rectangular or Cartesian form. And so it's very nice to have the flexibility to work in a different coordinate system.